1.
So let's practice some balancing equations here. And during this part of the lesson, I'm going to be sharing with you some little strategies that I have found work for me when I was balancing equations, when I was learning. So I will be sharing those same uh, little tips and tricks with you on some of these balancing equations. All right, so let's look at the first one here. Here we see mercury 2 oxide being heated and decomposing into mercury and oxygen. So there are 3 places you can put a coefficient. I'm just going to underline the 3 places you can put a coefficient. Coefficients do have to be in their lowest whole number ratios, and whenever you're finished, I typically ask my students to write your final answer out to the side, as I will demonstrate here today. I don't see anything that really stands out here as far as a starting point, a complicated part of the molecule. Uh, what I look for, first of all, is like odd numbers or very large subscripts, or if I see a combustion reaction, and I know you don't know what that is yet, but I will show you how to identify a combustion reaction. They tend to be pretty tricky to balance. So I'm going to show you a strategy that I use with those when we get to it. But when I don't see anything that really stands out, I just start at my reactant side and go element to element until everyone is balanced. Treat this as your equal sign. Your yield sign is like an equal sign. So when you're done, the number of atoms of mercury on this side have to equal the number of atoms of mercury on this side. The number of atoms of oxygen on this side has to equal the number of atoms of oxygen on this side. Right now, I have 1 mercury on this side, so I'm going to check over here, and I see I have 1 mercury on the product side. So right now, my mercuries are balanced. They're equal. So let's look at our oxygens. There's 1 oxygen on this side, but this subscript 2 means there are 2 oxygens over here. So I need to fix that. They're not balanced. So since there's 2 on this side, I'm going to come back over to my reactant side, and I'm going to put a coefficient of 2 here, and that would give me 2. You multiply the coefficient to the understood subscript for that atom. So 2 times 1 is 2 oxygens on this side, and I have understood 1. 1 times 2 is 2 oxygens on that side. Now, what this did is this now has my mercuries unbalanced. So now I have 2 mercuries on this side, and on this side I only have 1. So I should put a coefficient of 2 in front of the mercury, and that gives me 2 mercuries. So look at your coefficients, 2, 2, 1. And so that cannot be reduced. So you're going to come over and you're going to write your 2, 2, 1 as your answer. In this particular example, there will be 3 numbers I will be looking for, the 2, and the 1. All right, let's look at our second example. Now in our second example, it's a little more complicated chemical reaction here. We see a single replacement reaction. We will learn about the types of reactions in a later lesson. But I do see this odd number 3 here. This stands out to me. Now, the way I'm explaining this is a strategy that I use. Now, there is no one way that is always right to balance an equation. You just kind of learn some little tricks. I always try to start with the most complicated part of the molecule. So the 3 is odd. Odd numbers are typically harder to work with. So what I always try to do whenever I see odd numbers or very complicated parts of the molecule, I start there. And with an odd number, I always multiply that whole compound by 2 to make it an even number, because when you multiply anything by 2, it makes it even. This is going to automatically fix my oxygens as far as they're being odd. Now they're going to be even. So multiply and check it out. 2 times 3 gives me 6 oxygens on this side. So now come back over to this side, and you see that the water has 1 oxygen in it. So I need to get 6 oxygens on this side as well. So if I put a coefficient 6 here, 6 times 1 gives me 6 oxygens on both sides now. So now let's take a look at our irons. 2 times 2 gives me 4 irons here. Look on this side, I only have 1. So if I put a coefficient of 4, that's an easy fix. 4 times 1 is 4. I now have 4 irons on each side, and my oxygens are 6. Now the only element I have not balanced yet is the hydrogen. So 6 times 2 is 12 hydrogens. So I need to figure out how to get 12 hydrogens over here. Well, if I put a 6 here, 6 times 2 is 12 hydrogens. So I have 4 irons here, 4 irons here, 12 hydrogens here, 12 hydrogens here, and 6 oxygens here, and 2 times 3 is 6 oxygens here. Now remember, they do have to be, your coefficients do have to be in their lowest whole number ratio, so 2, 6, 2, 6 can be reduced, and so you want to reduce it. Your final answer, if you divide everything by 2, you get a 2, 3, 1, 3. That will be your answer. There are 4 coefficients needed to balance that equation. All right, let's look at number 3. I do not see any large or odd subscripts, so I'm just going to start here on this side. I have 2 hydrogens on this side, 2 hydrogens on this side, because the 1 times 2 gives me 2, 1 times 2 gives me 2. Now look at your oxygens. 1 times 1, I have 1 oxygen here, but 2 oxygens here, so they're not balanced. So let's come back over here. To get 2 oxygens on the reactant side, I need to put a coefficient of 2 here. That gives me 2 oxygens here, 2 oxygens here. 1 times 2 is 2, 2 times 1 is 2. Now, hydrogens. 2 times 2 is 4 hydrogens. So to get 4 hydrogens here, I need to put a 2 here. 2 times 2 is 2. So my coefficients end up being a 2, 2, 1. So come over to the side, 2, 2, 1. That cannot be reduced, so your answer is 2, 2, 1. All right, here on number 4. This reaction here is a reaction that we're going to come to find is known as a combustion reaction. A combustion reaction is defined as when you have a hydrocarbon. Notice this compound is composed of hydrogens and carbons. Hydrocarbons are very flammable, so they are combustible. And when you put them in the presence of oxygen and a little bit of heat, a spark, a little bit extra energy, it will ignite and combust. So combustion reactions are easy to identify because they all look very similar in that you will have a hydrocarbon plus oxygen, O2, and it will form carbon dioxide and water. These 2 products are always your products of a complete combustion reaction. Now, this one is a fairly easy combustion reaction to balance, but these can get very complicated. So what I'm going to show you here with this combustion reaction is I'm going to show you a little trick that I learned as I was a student and struggling with balancing these. And you won't really find this method in a textbook anywhere. I just kind of call it the switch trick for lack of a better name. But in order to balance a combustion very quickly, this method works every time. So here is the strategy, if you will. First of all, you want to think Hollister and Company. And you're thinking, what does Hollister and Company have to do with balancing an equation? Well, Hollister and Company, HCO, this gives us the order in which to attack your atoms or balance your atoms. So H is first, carbon's next, oxygen's last. Now the trick has to do with your hydrogens. You're going to switch. I call it the switch trick. It's really not switching something, but the hydrogens are the key. Look at your subscript of your hydrogen. Whatever this subscript is of your hydrogen, this number is the number you are going to put as a coefficient in front of the compound on this side that has hydrogen in it, which is always going to be water. So there's a 4 here. So I'm going to put a 4 coefficient in front of the water. Look at your hydrogen subscript here. This number is going to be put as a coefficient on the other side in front of the compound that has hydrogen in it. So in this case, it's the hydrocarbon. 2 here, so put a 2 in front of your hydrocarbon. So now notice, already I've got my hydrogens balanced. 2 times 4 is 8. 4 times 2 is 8. All right, so we've done our hydrogens. Now let's look at our carbons. Now, 2 times 1 is 2 carbons on this side. Now look over on this side, find your carbons. There's 1 carbon on this side. So I have 2 carbons on this side, 1 carbon on this side. So if we put a 2 here, 2 times 1 gives me 2 carbons. Now my carbons are balanced, so moving on to my oxygens. These are the ones that can be a little bit of a pain to balance. All right, so let's look on here. The reason this is more challenging is because in combustion reactions, both of your products